Prithvi.
Yeah,
Uh, Ganesh this side. While I'll just introduce myself first, okay. I'm Ganesh Ramdas Kudare. I have got around 7.3 years of experience in IT, and from that around 3.5 years in data engineering. Okay. So in data engineering, I have worked in extensively on like HDFS, worked on PySpark, Python, SQL, and Azure Cloud. In Azure Cloud, worked on Azure Databricks, Data Factory, Data Lake Synapse. Okay, and I have worked on around 3 to 4 banking projects, and currently I'm working in one of I would say a logistics organization. Okay, so you can maybe start with your introduction as well.
yeah. So, hi Ganesh, good afternoon. So,
Mm.
my name is Prithvi and I am from Pune. And I've been working with Infosys as a system engineering, big data engineering domain. And I have about 2.5 years of experience in data engineering domain. And talking about my skill set basically revolves around technologies like PySpark, SQL, Azure Databricks, Azure Data Factory, Azure Data Lake Storage, end-to-end, Azure Synapse Analytics.
Okay, so I'm saying these are tools and technologies you have used in your project, right?
Yeah, correct.
Okay, so maybe let's get started before Spark. Okay, do you have any high level understanding on Hadoop? Uh, Basically, how Hadoop is working, what are components of Hadoop? Do you have any understanding on that?
Yeah, sure. So Hadoop is basically a framework, as per my knowledge, which is used to solve big data related problems. And in Hadoop, basically, we have three core components: HDFS, MapReduce, and Yarn. So HDFS basically stands for Hadoop Distributed File System, which is used for distributed storage. And MapReduce is basically used for distributed processing. And Yarn is just like yet another resource negotiator, which provides resources for our Hadoop jobs. So this is basically these are the core components of Hadoop.
Okay. So looks like basically distributed processing and storage introduced by
Yeah,
Hadoop. And apart from these core components, there are few ecosystem technologies also there. Okay,
yeah,
if you are aware, like they have, I think, Scoop for ingestion. They have Woozy,
yeah,
HBase, Hive, and Pig also. Okay,
yeah.
yeah. Okay, that's good. Next question I wanted to understand, like, you are working on Spark. Okay, so
Yeah.
what is the reason we are moving from Hadoop to Spark, or we can say MapReduce to Spark? What are the reasons, or what are the disadvantages, if you are aware, we are moving from MapReduce to Spark?
So ideally, talking about MapReduce, like it is also a distributed processing framework in Hadoop. So there were some of the disadvantages with MapReduce, like it used to use the disk very heavily. Like after each stage, it used to write the results back to the disk and read the results from the disk. So it included a huge number of I/O operations, like read and write operations. Due to this, it degraded the performance, like performance was reduced. And also some other demerits were like MapReduce code was written in Java, which was very hard to write, and the lines of the code were getting very large as compared to other frameworks. So basically, and in MapReduce, it only supported batch processing part. It never supported the real-time processing as it supported in PySpark. So these were some of the disadvantages, and also in Hadoop part, we were bound to work with MapReduce. Like we were only thinking in map and reduce logic for every problem. So these were some of the demerits we faced with MapReduce. And talking about Spark, like Spark is much beyond than MapReduce. It basically it's famous for its in-memory computations, due to which it involves a less number of I/O operations, and we can also work on real-time processing part in uh, Apache Spark. So yeah, this is the reasons.
So you said Spark is in memory computation. Okay,
Yeah.
does Spark offer storage?
No, basically, it's like a plug and play compute engine. We can plug it with any other storage account like HDFS and maybe Google Cloud Storage or Amazon S3. So we can generally plug it with storage account. So it's like a compute engine basically.
Plain compute engine can be used with any of
Yeah,
resource manager, any of distributed storage.
yeah.
Okay, fine, good. Okay. So now we are in Spark. Okay. On a high level, I wanted to understand in Apache Spark. What are the levels? Okay, we can work in Spark. What are the options available to work in Spark? Layers, we can say. There are different APIs, right? Higher
Yeah.
level APIs and core APIs. So, can you throw a light on that? Maybe if you are aware.
Yeah, so in Apache Spark, basically we have two kinds of layers. Like we have Spark core APIs and higher level APIs. In Spark core APIs, we have RDDs. We work on RDDs, and talking about higher level APIs, we deal with Spark data frames and Spark SQL, Spark SQL. Hmm. So these are
Correct.
the two.
Yeah, and like again from RDDs we are like most of the times we use data frames and Spark SQL, right?
Yeah.
So what is the difference that data frames and Spark SQL are offering that RDD doesn't have? What is the reason
So
we are moving to data frames and Spark SQL? Or it is
in
recommended? Why it is recommended?
So generally, data frames and Spark SQL is recommended over RDDs because RDD generally provides more flexibility in case of processing, but the way of writing code in terms of RDD is very tough, we can say, and as compared to data frames and Spark SQL. And in data frames, basically, we get medium level flexibility, and the way of writing code is like a programmer friendly, more towards programmer friendly
Hmm.
and medium level tough. And talking about Spark SQL, it gives us very less flexibility, but it provides the easiest way to write the query. Like we can deal with this processing by using SQL kind of syntax in our Spark cluster. So basically, that's the major difference between these three.
Hmm. And what are the languages you can write? I would say a Spark code in. What languages you can use there?
We can write in Python with Spark. We can basically use PySpark.
Hmm.
Basically, we can even write it in Scala also.
Scala
Uh,
also, yeah, yeah. Python,
Python,
Scala, R,
Scala.
and Java we can.
Yeah.
Hmm. Okay. So, okay, I'm saying that you just said about RDD, right?
Yeah.
So, what are RDDs maybe? Can you just explain more about RDD? What is importance of RDD in Apache Spark?
So RDDs basically stands for Resilient Distributed Data Sets, and RDDs are the basic unit in Apache Spark which holds the data. And as the name suggests, like RDD, R stands for resilient. So resilience basically means that they are resilient to failures. Like we don't lose any particular RDD. They are not impacted by the failures basically. If we lost a particular RDD, we can recover that by applying transformations on the parent RDD. And talking about the features of RDD, like RDDs are immutable in nature. We can't make any changes in the existing RDD. So we end up creating new RDD by applying transformations on the existing RDD.
Okay, okay, correct. And any data frame Spark SQL code we write internally, basically it gets converted to RDD
Yeah,
code as RDD is basic unit. Okay.
yeah,
Okay, fine. Hmm. Okay, let's talk about maybe actions and transformations in Spark. Okay, so
yeah.
can you give me a brief idea what are transformations in Spark? Okay, what happens when we I would say execute a transformation? What happens when we execute action in Apache Spark?
So basically, transformations like are like the operations that we perform on our RDD or a data frame, and it basically leads to creation of a new RDD or a data frame. and they transformations are basically lazy. So when we perform a transformation or a data frame, they don't get executed immediately. So internally, they instead Spark will internally build a DAG of all of these transformations. Like DAG is basically the graphical representation of all our transformations. So internally, it builds the DAG of all of this transformation. And when we invoke an action over this transformation, the DAG basically gets optimized, like it's like an execution plan. So it will get optimized and it will give us results. So action basically, when an action is invoked, we get the results at the driver machine basically. And when we perform transformations, they are lazily evaluated. They don't get executed immediately. So this is
Mhm.
like,
When action is fired, like entire execution plan gets executed.
yeah,
Okay, fine. Mm, okay. Can you briefly explain me about a Spark architecture?
yeah. So as per Spark architecture, there are two things like one driver and multiple worker nodes. It's basically like a master slave architecture. So the driver basically acts like a master and the executor or the worker nodes basically acts as a slave. So generally, when we call an action, the driver will basically create the Spark context, which is generally the entry point to the Spark cluster. So the driver will basically ask for the driver will get launched, and it may be it get launched on one of the worker node or the client edgeway node, depending upon the deploy mode we have selected. So when the driver get launched, it will ask for the resources from the resource manager. So basically, the resource manager will provide resources to the driver in the form of executors or worker nodes. So these worker nodes will be now responsible for doing the actual tasks in the cluster and reporting the results back to the driver. And the driver will basically be responsible for generating various kinds of plans, like we have parse logical plan and analyze logical plan and optimize logical plan. So these are various kinds of plans. And also driver will be responsible for coordinating these tasks among the executors. So when all the tasks are done, basically the all the worker nodes will report the results back to the driver, and then basically the resources will be released and the driver program will get terminated. So this is basically the Spark architecture.
Good. Okay. You said about deployment modes. Okay.
Yeah,
Just so what are deployment modes and what are different scenarios we use them?
yeah. So in Spark, basically we have two kinds of deploy modes. Cluster mode and client mode. So the major difference between them is that in case of client mode, the driver basically uh, runs on one of the gateway node, or we can say it's client machine. And in case of cluster mode, the driver will work all or run on one of the worker nodes. So this are the is like the major difference between client mode and cluster mode. And generally, in case of production scenarios, we prefer to use cluster mode over client mode, because in case of client mode, our driver is present on the client machine. So if the in case of client machine goes down, then our driver will also go down. So as we know that the driver is the heart of the Spark application, so it may get affected. Our Spark application may get affected. So yeah, this is
Hmm.
the
Basically, in cluster mode, we can run the job. We can just log out from the system.
yeah.
It will run automatically. So that's what we prefer in production. Okay.
Yeah.
One more thing you said while answering the Spark architecture is different plans you said, like
Yeah.
past logical plan. Okay. So
Mm.
what are those plans that you're aware of? How many plans you're aware of, and what are those?
Yeah, so basically we firstly when we invoke and like when we submit the job using Spark-submit command, the driver will get launched, and basically the driver is responsible for generating all these kind of plans. So we basically have firstly we have this parse logical plan. In parse logical plan, basically it will Spark will internally check all the metadata related syntactical errors in our code, like if we have mentioned the correct syntax. So it basically validates over the syntax of our code. Once this get validated, then we have this analyze logical plan. In analyze logical plan, basically Spark tries to check the metadata related things, like if we have given the correct table names or column names. So after that, this plan gets validated, we will check for the basically we have this optimized logical plan. In optimized logical plan, we get various kinds of optimizations, like the it basically applies predicate push down internally. It will combine multiple projections into one. It will combine multiple filter operations into one. So we get this kind of optimizations. And after that, we have this physical plan. So in physical plan, basically Spark uses this catalyst optimizer, which is used to transform this optimized logical plan into most efficient physical plan on the basis of the cost-based and role-based optimizations. Like for example, if we it will check that if we are using joins, then it will make sure that we are using broadcast join according to the cost-based optimization. So yeah, these are
Hmm.
the various kind.
Yeah, just to correct, this catalyst optimizer is used or gets launched when we are in optimized logical plan. Okay, and in physical plan, it is like you said correctly, which join strategy to use or
Hmm.
which hash aggregate to use or sort aggregate to use. Okay, based on scenario, right? You mentioned while saying optimized logical plan, you mentioned about predicate push down. So you do
Yeah.
you have any idea what predicate push down is?
Yeah, predicate push down generally means, for example, like if we have a data frame and we are performing various kind of transformations like joins and group bys, and after that, like we are performing some 9 transformations, and after that we are performing a filter. So Spark will internally try to move these filter transformations on the, like firstly it will apply this filter transformation. Like this is basically the concept of predicate push down, so that irrelevant records get filtered at the initial stages.
Yeah, hmm,
So,
correct. So instead of processing on all the records
yeah,
in the start, it will just filter down and then it will reduce the number of records to be processed. Okay.
yeah,
Okay, fine. Few activities. So internally in Spark architecture, it creates driver and all these things happen. Resource manager provide resources.
yeah,
In Spark, there are so if you, I'm not sure if you're aware of Spark UI, but on Spark UI, we have few actions happening. We have few jobs,
yeah.
stages, and tasks. Okay. So do you have any idea what the job stages and tasks are?
Yeah, so generally when we invoke a Spark transformation, like we invoke a action on a particular data frame, then it leads to creation of jobs in our Spark UI. So basically, when we call an action, a job is triggered. A job will have a number of stages inside it. Like the basically the number of stages are marked by the number of shuffle boundaries. So number of stages is generally equal to the number of white transformations plus one. And after the stages, we will have the tasks. Like the task is the smallest unit in the Spark user interface. It is generally equal to the number of it is generally equal to the number of data frame partitions. So like this is the hierarchy of jobs,
Number of jobs basically equals to number of actions we are performing.
actions. Yeah,
Correct. Okay. Okay, so we are on transformations. So transformations, Spark transformations. What are Spark transformations that you are aware of? How many types of? I'm say not. I'm not asking about what transformations you are using, but what are on high level types of transformations in Spark?
one generally on high level we have these two types of transformations, like narrow transformations and wide transformations. So narrow transformations are basically the transformations where there's no shuffling of data involved. Like for example, filter map, flat map. So these are the kind of transformations. Like here, everything happens in the map phase. There is no shuffling activity involved. And talking about wide transformations, these are the transformations where shuffling activity takes place. shuffling will basically happen to perform some global aggregation. So this
Okay.
is the
Okay. So that's why that is wide transformation. Okay.
yeah.
Okay. Fine. Okay. Okay. So can you explain me at high level what is the difference between repartition and coalesce? Are you aware of repartition and
Yeah,
coalesce first?
yeah.
Okay, so what is
So
difference between both of these?
repartition is generally used to increase or decrease the number of partitions. So we tend to increase the number of partitions in scenarios like, let's say we have a file, we have a 100 node cluster, and we are dealing with a data set which is of 5 GB. So according to the block size of 128 MB, we'll get 40 partitions roughly in our data frame. So if we are having 100 node cluster and if we are getting 40 partitions, so at the max 40 partitions or 40 machines will be running, the rest 60 will be sitting idle. So in this case we can increase our parallelism by increasing the number of partitions. So in this case we can use basically repartition to increase the number of partitions. It is also used to decrease the number of partitions. And talking about coalesce, coalesce is generally used to decrease the number of partitions. And the main difference between both of them is like repartition, when it tries to decrease the number of partitions, it will try to reshuffle all the data across the partitions. And after the reshuffling activity, it will try to give the partition size of equal size after performing repartitioning. And talking about coalesce, coalesce doesn't involve any reshuffling activity. It will try to like merge the partitions on the similar same node, and it will give us the results. Like it just tries to merge the data on the same partitions and give us the output. And the partition size after coalesce may be of unequal size. So
Hmm,
this is
hmm,
the
okay. So best solution for decreasing number of partitions is coalesce, you are saying.
yeah.
Okay. Okay, fine, good. Um, okay, now let's little move to data frame and coding part slowly. Okay.
Yeah.
I wanted to understand before we create any data frame, right? Let's say I have some data stored in HDFS or let's say any cloud data lake, okay?
Yeah.
And I have to create a data frame out of that, okay? So, uh, what is recommended approach? Like, should I define the schema or should I enforce the schema? Because, sorry, should I enforce the schema or should I infer the schema? Because inferring schema is taking less lines of code, okay?
Yeah.
So what is the recommended approach?
Ideally, it's recommended that we should enforce the schema explicitly by ourselves instead of inferring the schema, because inferring the schema will basically it will put a load on the Spark system. Like Spark will have to internally scan the entire data to parse the data types, and there might be some issues also while inferring the schema. It might infer wrong schema, and we might end up getting the wrong data types. So generally, we are recommended that we should be enforcing the schema explicitly.
Okay. Okay. So now on schema enforcement, what are the ways or what are the methods for schema enforcement that you are aware of?
So basically, to define schema, we have two different ways. We have schema DDL, and next one is struct type, to which
Hmm.
we can enforce the schema.
Would you be able to write kind of code for both of these? I'll just give you,
Yeah,
let's
sure.
say, columns. Okay, you can share your screen.
Yeah, sure.
Okay, so we consider, let's say, employee ID as integer. Okay, then employee salary. Second column is employee salary, maybe again integer, and employee name. Okay. String. Okay. So just try to define using both the methods that you said.
So yeah, so firstly we'll use schema DDL method. For struct type, basically we need to import some function from the PySpark.
Good. Okay.
Yeah, so this is basically the struct type and this is schema DDL type.
Hmm. Yeah, in SpicePark.sql, the types you have to import struct field as well. Okay.
Yeah,
Okay. Fine. Okay. Hmm. So this data set is employee data set. We can say the first 1, 2, 3, 4, 5, 6, 7. It is just an ID. It's a kind of primary key. Then employee name, then employee salary, and the fourth column it's department. Okay, department of that employee. What we want is we want the employees in department wise employees. Okay, who are earning like max three salaries, I would say. Okay, so if let's say any of the employee earning same salaries, okay, let's say
okay.
employee one or two are having 80,000. Okay, so those
Hmm.
should be calculated. Okay, I want all
Okay,
the employees who are fitting in top three salaries each department wise.
okay. So for this scenario,
Understood
we
the
can
question, right?
generally, yeah, I
Okay,
understood the
okay,
question.
okay.
So for this, we'll basically we can use the dense rank function, like the window function.
Hmm.
We can define one window.
Yep, you can go ahead. You'll be
Yeah,
able
we
to
can.
write, right? You can go ahead, yeah.
Yeah, we can. We have created the data frame.
Mhm.
So we'll basically need to import the function using the dense rank function. Data frame. This will basically give us it will assign ranks to the employees according to the salary from highest to lowest, and
Mhm.
grouping of the basis of the particular department. So we want generally the employees with the top three salaries. So here we
Mhm.
can apply the filter like ranks is less than or equal to 3. So this will basically give us the names of all the employees,
Okay.
salaries. Yeah,
Hmm. Okay. So yeah, before defining window, you will have to just import the window
yeah,
from
correct. Yeah.
PySpark.sql window. You have to import a window, and it is that's correct. I think logic is absolutely correct. Okay. And window dot partition by. Okay. Fine.
Yeah.
Okay. So good. Famous thing. You just use tense rank. Okay.
Yeah.
So let me put you a simple, small data set just to you know understand the behavior of dense rank and row number. Okay, you can
Mm.
copy that in Notepad. Yeah. Okay. So let's consider these are, let's say, any some marks of students. Okay, marks of students.
Yeah.
Um, for each of this, you just write what will be dense rank, what will be rank, and what will be row number. So you just can put first column as marks. Okay, yeah, mask, and then you can give a tab rank, dense rank, anything, row number, rank, and dense rank. Hmm. Yeah.
So talking about row number, like row number will basically assign the sequential integers. Like
Mm-hmm.
it basically will give one, two,
Mm-hmm.
three, and four. Like it will give the sequential numbers.
Mm-hmm.
And talking about rank, it will basically
You can mention for
it will give
all the entries. For all the entries, you can mention.
yeah,
Maybe you can complete row number first. Okay.
and for rank it will basically, so these are the two similar values.
Hmm.
So after, in case of tie, it will give the similar values, but after that it will skip the next consecutive value. So after one and one, it will give three.
Okay.
Then it will give four. Here again it will give four. 27.
Mm-hmm.
So it tries to skip the next consecutive value. And
Mm-hmm.
talking about dense rank, it will give similar ranks to the same values, but after that it will not try to skip the next consecutive integer. It will basically apply the next, it will not skip the values.
Mm-hmm.
That's four. So yeah,
Okay. Good. Correct. Correct. Yeah. Mm, correct. Okay. I just asked this because you used N's rank, na? So I just asked
Yeah.
this question. Okay. Okay. Uh, just the next one code. Okay, I'm putting here in the chat. Okay. You just can copy from chat itself.
Yeah.
Okay, so this is like it's just the player's data. Okay, for example, Ganesh on 1st of Jan, date again you can consider YYMMDD in Spark format. Okay, no
Okay.
need to work on dates. So here data is like the match that Ganesh has played on 1st of January 2024. He has won that. Okay, Prithvi, the match
Okay.
played on 1st of Jan, lost that. Okay, then all like that. Okay, what I want is
Okay.
find the name of players who are having like consecutive wins. Consecutive wins, I mean to say, for example, Ganesh played his first match on 1st of Jan, okay, and then
Yeah.
Ganesh played on 6th of Jan, okay. So consecutively, he has won on one in first match and second match as well, okay. For him, I
Okay.
want you to find the players who are having consecutive wins. The names of players who are having consecutive wins.
So yeah, for the players and we want to find the consecutive wins. So
Hmm. Hmm.
for this again, we'll need to specify or create one window.
Hmm.
For that, we'll basically create window. So for each player, like we want who has won consecutively, so we can partition it over each player. And basically, we want consecutive. So we'll order this date column, order it in the descending order. So this will be our window.
Okay,
And
ordering in
like
ascending order.
we
Correct.
want to find out where they have consecutively win. So we'll basically want the next date. So in this case, we can apply the lead function.
Mm-hmm.
Yes, create one new column for the next match result. Next match result. And we basically perform a lead function on the result column. This window. So this will basically give us a new column here, like
Mm-hmm.
the next result. Basically, first it will try to group all the players and according to the date in the ascending order, and it will give us the next match result, whether he has won the match or not. So from that, we can basically apply a filter on this transformation. Like if the column of result is equal to win,
Mm-hmm.
and also column of next match result is equal to win. So after applying this filter, we'll get to know the names of the players who have won consecutively.
Mm-hmm. Okay.
We'll
Okay, good. Yeah. Just one thing. Once again, this you are specifying window, right? So window
Yeah,
specific, window spec, you are saying window dot partition by. It should be partition by, right? It's not only partition. It's partition by. Window dot
yeah,
partition
sorry,
by.
that, yeah, yeah, correct.
Okay. Okay. Fine. Good. Yeah. Uh, good. I think you can stop sharing. That's fine. Okay.
Mm,
Mm, okay. So you worked on Azure Cloud, right?
yeah, correct.
Okay. So what are services in Azure Cloud you have used so far?
So basically, in our project, we have used basically Azure Databricks for coding part and Azure Data Factory for basically ingestion part and orchestrating the pipelines. So these two services I have worked for.
Okay. Uh, okay. Let's say Databricks. Okay. So
Mm.
on high level, can you explain the Databricks architecture, how it looks like on high level?
So yeah, Databricks. Talking about Databricks architecture, we generally have two things here: the control plane and data plane. So the control plane mainly falls under our Databricks subscription. It consists of the Databricks file system, then the Databricks user interface and cluster metadata and all kind of things. And talking about the data plane, it mainly falls under our Azure subscription, and it basically consists of our blob storage account and network security group and some more things here. So these are the
NSG
two
and
things.
VNet kind of things.
Yeah,
Okay. 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 Databricks. So in data, so just a question. So let's say in Databricks I have Python notebook. Okay.
yeah,
In Python notebook, can I run a SQL query in my Python notebook?
yeah. We can, like in Databricks notebooks, we have this concept of magic commands through which we can run various kind of like various. We can use various languages like SQL. We can write SQL queries in our Databricks notebook too. It's basically a percentage, like
Hmm. So you said
percentage
about
SQL.
magic commands, right? What all
Yeah.
other I would say codes kind of you have used using magic command in Databricks? So percent SQL is one thing. What else you have used using magic command?
So basically, percentage fs like this is one command like through which we can uh, search for a like we can find the files in our Databricks file system
Hmm.
using percentage fs. We can like in case of Hadoop, like we use Hadoop fsls. So similarly in Databricks we can specify using percentage fs. You can
To access
search
this
over the
DBFS data.
yeah, correct.
Just to understand DBFS data. Okay, fine. Mm, okay. Mm, okay, let's say I have one notebook in Databricks. Okay, and I want
Mm,
to execute that notebook from some other notebook. That is requirement. I have created multiple notebooks. Okay, so from any
yeah.
another notebook, I have to trigger the notebook. Okay, let's say I have two notebooks, notebook one and two. So from notebook one, I have to execute notebook two. Is that possible in Databricks?
Yeah, so in Databricks, we have this notebook utility function through which we can basically try to run the child notebook from the wrapper notebook. And
Mm-hmm.
basically, it has one command like Databricks utility function, dbutils.notebook.run. So using this command, we can run the child notebook from the parent notebook. And in this command, it basically takes two parameters, like it will take the path of our child notebook, and the next thing it will take is like the timeout we need to specify. It
Okay,
will basically take two parameters.
correct. Okay. And okay, fine. So can I specify the parameters in this dbutils.notebook.run? Can I specify some parameters which I want, using which I want my next notebook to run? Okay, for example, let's say employee name. Okay, I want to specify a parameter as
Yeah,
employee name as Ganesh. Okay, and that employee name
yeah,
I want to use in the another notebook which I'm going to run. So can I specify that parameter in dbutils.notebook.run?
yeah. Even we can specify the parameters also.
Okay. Okay, fine, good. Um, okay. Mm, okay, not in terms of Databricks and in terms of data lake, okay.
Yeah,
So we have data lake in place, right? And there is something new, Delta Lake, that has got introduced, okay. So
yeah.
what do you know about data lake and delta lake? What are major differences and what are kind of advantages, disadvantages of each of those, data lake and delta lake?
So talking about data lake, like data lake is generally a storage repository where we can store a huge amount of data. It can hold any kind of data like structured, semi-structured, or unstructured, and it's basically cost effective and it's inexpensive to use. So basically, in data lake, we can there are some of the disadvantages with data lake, like it doesn't provide ACID guarantees, and also data lakes are not suitable for reporting and business intelligence use cases. So Delta Lake is introduced to tackle these problems, we can say. So Delta Lake is basically a slight optimization, we can say, made on top of our data lake. It's basically a storage layer which is introduced in our Spark. So basically, in Delta Lake, the data is basically stored in the Parquet format. Plus, additionally, it has the this one Delta log folder inside which it contains like all the transaction logs, like the transaction entities, metadata of the data, and structure of the data, and column names. So we have all of this handy in the Delta log folder. So through which it becomes very flexible to work with the processing part. And yeah, so this is like the major difference between the data lake
Mhm.
and Delta lake.
Hmm. Basically, it provides asset guarantees, okay.
Yeah,
Um, Fine. Versioning also we can achieve using delta lake.
yeah, correct.
Okay, fine. So,
Yeah.
and Data Factory, what are activities that you are aware in Data Factory? What are activities you have worked upon or like just seen or, activities in Data Factory? What are activities that you are aware of?
So the activities I am aware of are like the firstly the Databricks notebook activity is also one of the activity. Then we have this get metadata activity. Then we have this if condition activity. Then we have this mapping data flow activity, and we have this for each activity. So these are the like kind of activities which I have worked on.
Okay. Okay. Fine. Last question from me. So you said you are aware of Databricks, Data Factory, okay,
Yeah,
and Synapse, right? So let's say we have one scenario, okay. Let's say some any taxi service is giving me some data, okay. It's one time task, yearly once I'm getting that data, okay, and that data I just have to find a number of rides in a particular country city wise, okay. Let's say in India we have four cities, okay, so we just have to group by on country and city, okay. I'm just getting that every year, okay, yearly once I have to run that pipeline, not a big computation task, okay.
okay.
So what you will prefer? Will you prefer Databricks for that? Will you prefer Synapse or will you prefer Data Factory? What you will use to handle this scenario?
So as you mentioned that the data is generally coming once in a year. and we need to run that pipeline just once in a year. So we can consider it running that pipeline using Azure Data Factory service. So in Azure Data Factory service, we generally have this mapping data flow activity through which we can perform basic level transformations without writing the logic. So we can use this mapping data flow activity in Azure Data Factory to perform the aggregation as we are receiving
Yeah.
the data once in a year.
Just a simple aggregation around, I think, country and
Yeah,
city. Okay. Yeah, Databricks we can go when we have like huge amount of
some
data. We have
complex.
pipelines here to be run. I can say to be run continuously. Okay, compute intensive data. Okay.
Yeah,
Okay, fine, good. Good, Prithvi. You have any questions for me?
yeah. No, nothing from my side as well.
Okay, okay, fine.